Hello everyone, in this video I am going to discuss about the differences between fixed partitioning and dynamic partitioning in memory management in operating systems. So let us start with the fixed na partition. So in fixed na partition, it involves dividing the system's memory into fixed size partitions or regions. So it can be of an equal size or of equal size. In the first na illustration here, you can see a sample na illustration of the main memory. And we have to allocate a space for the OS, as you can see in both of the illustrations. And in this first diagram, as you can see, it is divided into 4 partitions of an equal size. Partition 1 is of 300K, 2 and 3 of 100K, and partition 4, 200K na MB. But we can also partition it with an equal na size. Of course, we still have to have a space allocated for the OS. And as you can see, partition 1 to 6 are all 100A. They have identical na sizes. Okay, so each na partition is allocated to a specific na process. And the size of each partition remains constant throughout the execution. That's why we say that it is a fixed na partition, because the size of the partitions are not changing dynamically. It will remain constant. Okay, and each of these partition, of course, we have queuing processes, right? And where are we going to load all of these processes? So let's say this partition 1 is already allocated with a certain process, then that certain process will be occupying the whole na partition. Okay, any program, no matter how small, occupies an entire na partition. So let's say if this partition 1 is 300K, and if we have a process that has only a size 50K, then this partition 1 will still be for that process. No other process can use this partition 1. Okay, so as long as the process size is smaller than or equal to the partition size, so we can load that in that partition. Okay, so of course, there are some advantages of fixed partitioning, since as we mentioned, the partition size remains constant throughout the execution. So when implementing it, it is relatively simple, since again, the partitions are predefined and they do not change dynamically. And in terms of memory allocation and the allocation, it will also be faster, since the system knows the fixed na location of each na process. So if a certain process has already been loaded in partition 1, then all throughout the execution, that certain process will be found in partition 1. So it is easier to look for it. So it is easier to allocate and deallocate. Now, let us have some example. And let's say we have this P1 of size 200K, P2 of size 50K. So P1 and P2 refer to process 1 and process 2. P3 of size 20K and P4 of size 250K. So, and in order for us to be able to execute this, we have to load this into the memory, right? Because in our process, the CPU has to fetch the instructions from the main memory. Okay. Now, the question is, how are we going to allocate this process with the fixed na partition? So as you can see here, we have a partitioned main memory of an equal na sizes. Partition 1 has 300K, 2 and 3 has 100K, and partition 4, 200K. So if the certain process is less than or equal to the partition, then we can load that in that certain partition. Okay, so the P1 may be loaded in this partition 4. Okay, since as you can see, P1 is of size 200K. Now, the P1 will be occupying this whole na partition. Okay, and P2 of size 50K may be loaded in partition 2 or in partition 3. So let's say we load P2 in partition 3. So as you can see here, there are some spaces that are not occupied or free, because we mentioned here that in the fixed na partition, any program, no matter how small, occupies an entire na partition. So the process size may be less than or equal to the partition size. Okay, so we load P2 here and P3 of size 20K. So the most optimal na partition it could be loaded to is in partition 2. So see that there are also some spaces here that are not occupied. So P4 may be loaded in the last na partition, and this P4 is also less than the size of P4, which is 250K, is also less than or equal to the partition size. Okay, so as you can see, there are a lot of wasted na spaces. Okay, and a program may not fit in a partition, as you have already seen in these examples. And another another problem is that what if a certain process is so much bigger compared to the fixed na partitions that we have? So what are we going to do? So assuming that we have a process which has a size of 500K, which partition are we going to load that process? Okay, can we break it down into chunks? So the programmer must design the program with overlays. And the memory use is inefficient since any program, no matter how small, occupies an entire partition. And you have seen that there are a lot of wasted na spaces. Okay? And this results in internal na fragmentation. So what is internal fragmentation? So it means that the partition may be larger than the memory requirements of a process, resulting in a wasted na space. So what are other disadvantages or issues with fixed na partition? So it has a limited na flexibility. The fixed size of the partitions limit the system's ability to accommodate processes of varying sizes and leading to inefficient memory utilization. Okay, now what could be a possible solution for fixed na partitioning? So it could be the dynamic na partitioning. So dynamic na partitioning will help overcome the difficulties caused by the process of fixed na partitioning. So in here, the memory is divided into variable size na partitions based on the size of the process being executed. So unlike the fixed na partitioning, we don't have a fixed na predefined na partitions or regions. Okay, so the size of the partition will vary depending on the size of the process that we want to execute. Okay, so assuming that we have P1 of size 200K, so that this will be the size of the partition. So as you can see, we have the main memory here, and we have allocated some space for the OS. Okay, and as you can see here, we have a P1 of size 200K. So we load the size then of this partition is 200K, which is equal to the size of the of this process. And we have a P2 of size 50K, so only 50K is also allocated for the P2. And if P4 has a size 250K, then 250K is also allotted for P4. And we can assign it anywhere in the main memory, or of course, it's the OS that decides where in the memory it will be allocated. And then for P3, we have to look for available or free memories that has size 20K. Okay, and you can see that there are some free spaces here that we can still load another process with. And as you can see, it is more efficient compared to the fixed na partitioning. So let's see here again. So in the first na OS, let's say we have a process A. So process A is allocated this memory, and then we have another process that wants to be loaded, process B, and then another process C. So we just add it dynamically, and given the memory that it needs. Now in here, A is done, and we still have B and C, and then D wants to get executed. So we look for spaces where D can fit. so it can be loaded in this memory where the A was recently executed. So that's the difference again with dynamic partitioning and fixed partitioning. So if this in fixed partitioning, if this space was allocated for A, then no other process can enter it. Okay, so but in this case, since A is done executing, then we can dynamically add D here. Okay, and now B is done executing and A wants to execute again, so we can reload A in some other space. Okay, so memory allocation changes as the processes come into the memory and when the processes leave memory. So when does that happen? When it is swapped to disk or if the process is done with its execution. And as you can see here, there are some gray regions that represent the unused memory. Okay, and again, the process size here is equal to the partition size. And as you have seen, the dynamic partitioning has a more efficient memory utilization compared to fixed partitioning because in dynamic partitioning, it helps maximize utilization by allocating memory based on the process requirements or based on the size of the process. And it minimizes the internal na fragmentation. So kung ano yung kailangan ng process, yun lang yung ibibigay sa kanya. But for the fixed na partitioning, kahit na sobrang liit lang ng process, if yun lang yung available na partition na pwede niyang pasukan, so ipapasok pa rin siya doon kahit madaming mga wasted na spaces. Okay? And it is also flexible because it can accommodate processes of varying sizes, allowing for better resource na utilization. And with dynamic na utilization, it is possible to execute more processes simultaneously, leading to improved system throughput. Okay, but compared to the fixed na partitioning, the memory management using this model is more complicated. The allocation and the allocation algorithms for dynamic partitioning is difficult to implement and may impact system performance. So in dynamic partitioning, there are some or various memory allocation algorithms such as the first fit, best fit, worst fit, and we are going to check later how these are or how the differences between these algorithms and how we can apply it in both dynamic partitioning as well as in fixed partitioning. Okay, so thank you for listening.